Hello, ladies and gentlemen. I hope you are all doing well. Root Beer here, and I am happy to announce we are at the end of the 2018 Pascal. It is the very last question, question number 25. So real quick, if you haven't tried it, feel free to pause the video and give it a try, because we are going into it right now. Question 25. PJ, I assume this is a reference to JP, who's actually a fellow who makes up these contests. Doesn't really matter, though. PJ starts with m equals 500 and chooses a positive integer n, somewhere between 1 and 499 inclusive. He applies the following algorithm to m and n. PJ sets r equal to the remainder when m is divided by n. Is this just going to be the Euclidean algorithm or something? Okay, so he does that, gets the remainder. I don't know, let's pick n is 11, just as a little sort of side thing. Okay, so if suppose he does n is 11, then 500 divided by 11 is going to be 46. Nope, that's too much. 45 with a remainder. With a remainder of 5. Okay. So then if r is equal to 0, it's not. PJ would set s equal to 0. Fine. If r is greater than 0, it is. PJ sets s equal to the remainder when n is divided by r. So 11 divided by 5 is 2, with a remainder of 1. If s equals 0, then PJ sets t equal to 0. Fine. If s is greater than 0, which it is in this case, PJ sets s equal to the remainder when r is divided by s. Yeah, this is basically the standard Euclidean algorithm. Remainder when 5 is divided by 1, well, that would still be 0 in this case. Okay, and they're doing an example for me. When n is 8, we get a remainder of 4, because 496 is a multiple of 8, and then you have 4 more to get up to 500. And then 8 is a multiple of 4, so s is 0, and therefore, automatically, by this condition, t is 0. For how many of the positive integers n, with n in the given range, does PJ's algorithm give an r between 1 and 15, an s between 2 and 9, and t equal to 0? Okay. So, it's all about remainders, right? So, what would this look like? So I might say, suppose we had such an n, the ones that we're looking for. Then we know m divided by n leaves a remainder of r. Well, another way of saying that is m is some multiple of n plus r. Okay? And if r is between 15 and 1, then, and I know m is 500, then I could say 500 minus r is a multiple of k. Some multiple of n. So specifically I can say that nk must be at least 499, but at most, taking away 15, it would be 80. Okay, so that's the range based on the biggest values that s can be. No, not r, s, r, that r can be. Okay. So, I suppose in theory we could take each of the 15 numbers in this range, and n must be a factor of them. So then I guess we could take each one in turn, each of those many factors, and say, all right, let's plug that n into the algorithm and see what r, well, we know we'll get a good r, but what s and t we get. Because we need t to end up being equal to 0. And s has to be in a particular range as well. Now, that would work, but I think that's going to be time consuming. I suggest we do the same process, because we know the range s has to be in. Do the same process to try and work down what r could possibly be, and things like that. And in fact, maybe the better idea would have been to start with the t, figure out an s, and then figure out an r, but I'm liking this, but I think we could probably narrow down what r has to be. So we'll see. But just getting back into it, we know that n, whatever n happens to be, is going to be r times, I don't know, L plus S. Right? That's the process. N is some multiple of R plus the remainder. This is always how it works with our remainders. Okay, so we know that S is between 2 and 9, right? 2 and 9. Okay, and R is between 1 and 15. Now, issue here is that I don't know what n is. So where this 500 worked out really nicely, I have no idea what n is. But I suppose we could say RL is less than n minus 2, or less than or equal to n minus 2, and greater than or equal to n minus 9. And then from there, what do we say? R is S times, we've already used M, so let's go with J, plus T, because T is the remainder when you divide R by S. Although, now that I'm thinking about it, what about all this process here? Oh wait, it doesn't matter. Because S will never be 0, so I don't know why they're telling us this information. And R will never be 0, so I don't know why they told us that information. I guess somebody just sort of copied the extended Euclidean algorithm and then came up with the question? Maybe? I don't know. But we'll never have to deal with S being equal to 0 and therefore T being equal to 0. So, this is all fine. But T is equal to 0. So R is a multiple of S. So this does narrow down what R can be. And if R is a multiple of S, N must be a multiple of S. Because N is RL plus S, but R is just Sj, so we get SJL plus S. This is SJL plus 1. N is a multiple of S. Not only that, same thing up here, 500 is a multiple of S, and that should narrow down, because there's only so many multiples of 500 in this range. So that can narrow down what the S's can be, that would narrow down what the R's can be, and that should, in theory, narrow down what the N's can be, I think. So let's just quickly write that up. 500 is NK plus R, but that's SJL plus 1K plus SJ. So that's SJLK plus K plus J. S is a factor of 500. So what are the factors of 500? Which is 100 times 5, so that's 2 to the 2 times 5 to the 3. Well, possible values for S. We know S has to be between 2 and 9. So what could we have? 2, 3, 4, 5, 6, 7, 8, 9. 9's off the table, 8's off the table, 7, 6. There's no multiples of 3. It could really just be 2. 4, and 5. So do we want to do cases now of the possible R values? So let's try something like this. If S is 5, I know R has to be in this range. So R could be 5, 10, or 15. But n times k is then going to be 500 minus 5, 500 minus 10, or 500 minus 15. You'll notice these are all multiples of 5. But, so that would be R is 5, R is 10, R is 15. But we also have to be careful because when we do the remainder of these numbers divided... Oh, no. Those aren't the ones that we divide by R. So, n divided by R needs to be S. That's what we have to have here. Uh, 500 is nk plus R. I was about to say R, n needs to be a multiple of R, but that's not the case. So that can't help. Do we really just want to factor these? So n has to be a factor of 495, but also leave a remainder of 5 when I divide by R equals 5. You can't leave a remainder of 5 when you divide by 5, so R can never be S. So that's useful. So 5's out, so is this one. So that's nice. That's narrowing down on our work. So 490 has factors of, well, I know it's got to have a factor of 5. So it's 98 times 5. 98 is 2 times 7 squared. So what could n be here? And remember, n has to be a multiple of s, so n has to have the 5. So n could be 5. That's not going to work. Oh, wait. Could it work? No. N can't be S either because S is a factor of 500. And so if I divide 500 by 5, for example, I'll have no R. So R has to be bigger than S, N has to be bigger than R, otherwise you won't get the remainder. So 5 would have worked, but we could have 10, that won't work. We could have 5 times 7, which is 35. We could have 70. What else could we have? So I've got to have the 5. I could either have a 2 and a couple 7s. We could have 490. And then 90 or 49 multiplied by 5, 245. So with R equals 10, do I get a remainder of S equals 5 when I divide here? Only with these two. So we're starting to get some possibilities, although I'm not liking how long this is taking, so I feel like I'm missing some theory. And if you ever reach that point where you're doing a question, you think, okay, I've got something that works, but it's taking me a long time to get this case, and then finally this case, and this case, and this case. You really have a choice, and it's a very tough choice to make. Do you stop what you're doing that you know will work but will take time, and try and redevelop the theory in the hopes of going faster? but you don't even know if there's more theory to develop. Maybe the question really is just intended to take me 10 whole minutes of furious computation. Okay? Probably not, but what if you've reached the limit of what you can learn? Okay, that's sort of the challenge there. So, well, I've learned a few things. R must be bigger than S, N must be bigger than R, so that should hopefully narrow some things down. I'm going to continue looking here and see exactly what else I can see. Okay. So, what's our other case? 485. So, NK is 485. Again, I know I have a factor of 5, and that needs to stay with the N. And I know, okay, so 97, oh, that's a prime. That makes me feel good. Because there's only going to be 2 factors that involve the 5 here. 5 and 585. Can't have the 5 here. And what happens when I divide by, in this case, R has to be 15. What happens when we divide 485 by 15? Just grabbing my calculator, I get a remainder of 5, which is S, which is exactly what I want. So this one also works. Okay, so that was just the case with S equals 5. We still have 4 and 2 to go. Hopefully, with them being powers of each other, this might go a little faster. So R is between 1 and 15. What are the possible values for R? Well, R could be 4, 8, 12, and that's really it, because the next one would be 16. Now, it can never be 4. And now NK must be 500 minus 496 if R, that would be if R is 4, which isn't allowed. 492, and that's if R is 8. Or it could be 488, and that's if R is 12. Okay. And remember, whatever N I get when I divide it by R needs to leave a remainder of S. So that's important to know as well. Okay, NK being equal to 492. I'm not liking this, but I know it's got to have a factor of 4, and that factor of 4 needs to stay with the N. So 492 divided by 4 is 123, which turns into 4 times 3 times 41. So N could be, we need to have multiples of 4 here, so 4, 12, 4 times 3, 164, multiplying 4 by the 41, or 492. Now, it can't be 4, because that would leave a remain, because the N has to be bigger than my R, which in this case is 8. When I divide 12 by 8, I can get a remainder of 4, so that works out. When I divide 164, well, I'm going a little faster, by 8, that'll leave a remainder of 4. And when I leave divide 492 by 8, that will also leave a remainder of 4. So these 3 all work. So I think in total we've got 6 going on. Now let's just pause and take a look at the possible answers to see where we are. 14, 12, 16, 15, 13. So we're, I would say, about halfway there. Okay, well, we're halfway through our second of 3 cases, so that's making progress. That really is. All right, next case. NK being equal to 488. What multiples do we have here? We've got a 4. The 4 needs to stay with N, but what else can we have? 488 divided by 4. 122. Oh, I guess I could have just subtracted off 1 from the 123. Now 122, I can see there's going to be a factor of 2 there. 2 times 61. Again, N could be 4, 8. Both of these will be thrown away because N needs to be greater than R. We could have 4 times 61, so that's 24, 4. And we could have 488 itself. So 488, when I divide you by 8, I get 61. So that's an even division. That would have made S 0. That's not allowed. 244 when I divide by 8. Gives me a remainder of 4, so we're good to go. So that's our 7th possibility. So I'll say I have 4 on this page, 3 on this page. Final situation, S equals 2. R could be 2, 4, 6, 8, 10, 12, 14. It's never going to be 2. So there we go. So this gives me NK could be 496 when R is 4. 494 when R is 6. 492 when R is 8. But this won't give me... This would imply the S is 4. We just went over that. 492 gives a remainder of S is 4. So automatically that one's out. Same with the 12. I believe we've already dealt with that. Oh! Wait a minute. This was R equals 12. And I was dividing by 8. 244. Glad I caught that error. Divided by 12. Gives me a remainder of 4. So that works out. But how about 488 divided by 12? Gives me a remainder of 8. Okay, so that one's still out. So we could have 488. I'm wondering if that might be something that's sneaky. Anyway, 490. But we've already dealt with R is 10. Did we have any multiples that failed there? So if NK is 490, I'm starting to think that I might just want to do these naturally. Because I don't think it's going to take too much extra time, and I especially don't want to get caught in some sort of elaborate trap by assuming something will work or won't work. Okay, so n needs to be a multiple of s. That is to say, it's got to have a factor of 2, but for the first one, we can't have a factor of 4. So 496 divided by 2. So 2 times 4, 248. And that's going to be 2 times, well, there's 8 here and the 31. Now, I don't want to take any of these 8s because then n is a multiple of 4. So n could be 2 or 61. So I'm speeding things up. Or sorry, 62. And 62 when divided by 4 does leave a remainder of 2. So that one's good to go. And of course, 2 is right out. How about 494? So again, we need to keep a remainder. So that'll be 2, 2, 4, 7. I can't remember if that's prime. I don't think it is. Just checking it on my calculator. I need to go up to divisibility by 13 is something that needs to be checked. Oh, 13 times 9, there we go. So 2 times 13 times 19. Alright, so 2 times any odd will leave a remainder of 2 when divided by 4. So we could get 2, we could get 26, we could get 38, or we could get 2 times all of them, which is 494. So any of these will work. Okay. One other thing to note, we don't have any overlaps. There's no overlap in the numbers that have been dealt with. Okay, what else could we have? NK being equal to 492. Now, this time n needs to be a multiple of 2. So we're going to get 2 times 246. We don't want any of the multiples of 2 in there. So 246 divided by 2. 123. So 2 times 2 times 123. So that's 2 times 3 times 41 times another 2, but we don't really care about him. So n could be 2, n could be 6. Oops. I am all sorts of awful today. Because these ones down here are supposed to be supposed to have divisibility by 6. That one leaves a remainder of 2. That one leaves a remainder of 2. 494. Do we leave a remainder of 2 when we divide by 6? We do. Okay, so these ones did work. But I realized I divided them by r equals 4, and that's not the case. So 4 is out. 6. Here we have to divide by 8, so I need a remainder of 2 when you divide by 8. We could have 2, 6, 82, 246, and the others will leave some multiple of 4 when you divide by 8. So it'll be a remainder of 4, so we don't need to worry about those ones. There we go. 2, 6. All of these when you divide by 8, so these ones are out just for being too small. 82 divided by 8 leaves a remainder of 2, so that works. 246 when you divide by 8, well, that's 240 is 8 times 30. That would leave a remainder of 6, so that one's out. There we go. So we had 4 on this page. And we've got 10, 12, and 14 left, so the end is absolutely in sight. So r equals 10, nk equals 490. So I need to leave a remainder of 2 when I divide by 10. So this is 2 times 5 times 7 squared. So we could have 2, we could have 10, we could have 14, we could have 30. Well, we need a multiple of 2 in there. So we could have 70. What else could we have? 1 plus 1, 2 plus 1. So there should be 6 numbers that we can choose. 490 is one of them, and what's the last one? 98, of course. 2 times 48. Alright, dividing by 10. None of these have a remainder of 2 except for the 2, so they're all out. Nothing to do there. Okay, 12, and then we'll finally have 14, and then we'll count everything up. So nk needed to be 488. We have been down this route before, but now we need to leave a remainder of 2 when we divide by 12, not a remainder of 4 as we had previously. 488 is 488 divided by 8, 61. Okay, so n needs to be a multiple of 2. If it's a multiple of 4 or 8, then when you divide by... I don't think that works, actually. So n could be 2, 4, 8, or 122, or 488, or 244. These ones are out. This one leaves a remainder of 2. This one leaves a remainder of 4. And this one leaves a remainder of 8. So we only have 1 coming from this group. And finally 14. So nk is 486. What are the factors of 486? So it'll be 2 times 243, and that's 2 times 3 to the 5. N needs to be a multiple of 2, so we could have 2, 6, just multiply powers of 3 by 2. So 18, 54, 162, and finally 486. Divide each of them by 14. We should get a remainder of 2. This is not one that does. 54 minus 2 is 52, which is not a multiple of 14. 162 minus 2 is not a multiple of 14. 486 minus 2 is not a multiple of 14. So it looks like we only got 1 on this page. That seems kind of odd. 1, 4 is 5. Another 4 is 9. Another 3 is 12. And that's it. So was 12 one of the possibilities, or has something gone wrong? There we go, 12. I'm a little suspicious because it's the lowest number, but the math seems to all check out. Let's just give it a quick once over for method. I do feel like there might have been a bit more theory that could have been developed. But there we go. With the n is 5 cases, just real quickly. This whole area was r is 10, so you couldn't have any of the multiples of 10, so 235 and 245 were the only ones that should work. What about r is 15? That's a multiple of 60 plus 5, so that does indeed work, and 97 is prime. So the last 2-digit prime. So, okay, we do get 3 cases there. 12 divided by 8 leaves a remainder of 4. 160 is a multiple of 8. And 490, are you... Oh, no, it would have to be 488, and that is a multiple of 8. Okay. Down here, we could have 4, we could have 8, but of course those are too big, because this time r is 12. Multiple of 4, but then that would become a multiple of 8, so that's all good. And there's, with these guys, there's 4 possibilities to consider. Alright, the numbers are really working out here. $62. Now we did have an extra 8 here. But with r is 4, as soon as we had an extra 2, that would give me a multiple of 4, so that can't be allowed, so that's why we ignored that. Now down here, r is 6. That one is the one we had to be careful about. We only have 4 multiples of 2 that we can care about, because it's to the power 1 and to the power 1. And all of them worked out fine. 24 plus 2, 36 plus 2, and 492 plus 2. And over here, 82 works. And of course the 2 and the 6 are gone. And we can ignore this 2. That didn't contribute because that would give a remainder of 4. 24 gives a remainder of 4. Why 24? 12 gives a remainder of 4. Said the wrong thing. This gives a remainder of 6 when divided by 8, but then that would also turn into a remainder of 4 if you multiplied it by 2. So, yeah, even that 2 wouldn't do anything. So we get 1, 2, 3. Oh, scary. Almost, so I guess my count of 12 was wrong, because this 81 over here, for some reason, didn't notice it until I saw it in bold with blue. Now I want to check 1, 2, well, let's put a blue box around him as well. But 1, 2, 3, 4, 5. Good count there. Okay, so I only miscounted in one place, but I guess that bumps up to 13. Oh, that would have been a disaster. I hate when that happens on a multiple choice contest, because I would have bubbled in B here, but in fact we want E. So I'm confident in the method. We haven't had a single failure, so I'm not going to double check 122, but I'm glad I caught that mistake. Otherwise, I would have been doomed. I would have been doomed. Lost 8 marks despite having completely worked everything out. It's a shame. That's one of the reasons I do prefer a good written contest to a good multiple choice contest, because they're kind of all or nothing, which is a bit of a shame, because I don't know, I've wasted, not wasted, but I took about a half hour to do the question, and it would have all been wasted if I had bubbled in 12 had I been writing it for real. Overall, question, it was an okay question. I find there's a trend for the question 25s on the Pascal, Cayley format, the PCF papers, to involve more casework, I feel, than they used to. So certainly the amount of casework here, fine. I think maybe I could have developed a bit more theory to reduce it, but yeah, I would say going forward, especially if you're writing more recent year contests, to expect there to be a little bit of theory, but then some cases that you have to work out. Not always, but I find that there's a lot of that sort of busy work and not the aha moments that used to happen in the past on these. Not experimentation and pattern recognition, just sort of slogging through factors. Although maybe I'm just a little cranky because it's been going on for... I've been recording for quite some time. But there we go. So that finishes up the Pascal. So that was our grade 9 level 2018 paper. Multiple choice if you want a grade 9 written paper. Fryer 2018, certainly good if you're looking for something a bit of a step up. Cayley 2018 is a grade 10, but still multiple choice level paper. So you can take a look at any of those. You can take a look at really anything. And if I don't have a contest, check the Waterloo page, because they might have something up that I haven't gone through yet. But other than that, happy math contesting. Sounds weird. But have yourself a wonderful day. Have yourself some wonderful math. And I will see you in the next video.